Welcome, Time Explorers. Today we are going back in time to visit the explosion of life that kickstarted life on Earth and land as we know it. 500 million years ago, we see a land without trees, without grass, without anything as we know it, and it's a spark of life that still stumps scientists today. And then here we see some amazing species that appear for the first time in the fossil record. 542 million years ago, the Cambrian period is probably one of the longest ones, which is spanning 54 million years long. And I'm going to show you what the world looked like around that time. So around Pangea, or around the Cambrian, there wasn't really much land other than the supercontinent Gondwana, which consists of Australia, Africa, Antarctica, India, and South America. And everyone's thinking, what about Pangea, the supercontinent we learned back in elementary school? We're throwing that out the window because Pangea was way after this. There's a lot of bursts in oxygen cycling in the ocean, which some new research says that is a reason for the Cambrian explosion in the first place. And there was some life before, such as these two figures shown here, but they weren't really complex as the Cambrian life that we'll see future. And then bam, suddenly within the next few million years, there's life on Earth that looks more complex, such as these fossils here and this trilobite fossil here. And more fossils are showing signs of morphology, which is like a variety in size, shape, and body variety shape. Such as in complex structures such as the cardiovascular system and segmentation, which we see in most insects now today. With this cycle of evolution, we see many different types of body shapes, with tube-shaped, or like snails and other mollusks today with shells, and segmented body shapes like I said before. Segmentation, biomineralism, and complex structures are all features that make up of all Cambrian life that we know of. The Cambrian life introduced us to 5 main groups of animals that we now know today: arthropods, mollusks, annelids, which are worms, chordates, which is what the group humans are part of, which they have a spinal cord either in the fetus stage or throughout their entire life. And then here we are going to take a first look at one of the fossils that is the first that we find. Of the paica, and is suggested to be moving around much like an eel, using up and down motions with its back end. The next fossil we're going to take a look at is the trilobite, and the trilobites are part of the arthropod class, which is one of the longest and most commonly found species, with over 22,000 types and lasting over 270 million years. And then here we're going to take a look at one of the early signs of stem-based arthropods, Opabina. Opabina, as you can see, is pretty odd just by looking at it. It has 5 eyes, unlike most animals known today, which have even amounts of eyes. These eyes are suggested to be, the 2 front ones are suggested to look side to side. The back 2 are decided to look diagonal directions to see up and down, and then the 5th eye in the middle is suggested to just look up. All right, and now that we have concluded our tour of time, let us take a trip back. And throughout this trip, we learned what the world looked like throughout the Cambrian period, what the Cambrian explosion was and the new life that came from it, and the life introduced.